When something is as incredibly difficult to get to as Mercury, it is extremely tricky to study. Which is one of the reasons why in all of human history there have only ever been 2 missions to Mercury, with just one more on the way.
The closest planet to the Sun remains an enigma for scientists. Its proximity to the Sun and distance from Earth discourages in-depth research and analysis, as sending probes to Mercury is both expensive and dangerous. Fortunately, NASA has received real images of Mercury, thanks to successful probes like the Mariner 10 and Messenger that orbited the mysterious planet, allowing us a unique opportunity to study it up close. Mercury is the smallest planet in our solar system, and although it is the closest to the Sun, it's not the hottest. Just like Venus and Earth, Mercury is a rocky planet with a solid surface covered with craters. Unlike other planets in our solar system that pride themselves on multiple moons, Mercury has no moons, which adds to the planet's mystery. It has no atmosphere, and the planet spins slowly compared to Earth, which means one day on Mercury is much longer than we'd expect. Even though days are longer on Mercury, it takes only 88 Earth days to make a complete orbit around the Sun. Imagine celebrating your birthday every 3 months. But before you pack your bags to catch the next spacecraft to Mercury, you should know that days on Mercury are quite different than here on Earth. For us, the Sun rises and sets each and every day, but since Mercury has a slow spin and short year, the planet witnesses a sunrise every 180 Earth days. Mercury was a mystery to astronomers until NASA's Mariner 10 became the first spacecraft to study the planet. The probe managed a successful flyby of Mercury on March 29, 1974, but it wasn't the only planet Mariner 10 saw up close. Its mission also included the exploration of Venus. Mariner 10 managed many firsts. It was the first spacecraft to explore 2 planets in a single mission. It was the first to use a gravity assist to change its flight path. Mariner 10 used Venus's gravity assist to reach Mercury. It was the first to return to its target after an initial encounter, and it was also the first spacecraft to use solar wind to manage its orientation during flight. Mariner 10's primary mission was to study Mercury's atmosphere, if any, and its surface and physical characteristics. When the spacecraft approached the innermost planet, the photos it sent began to show a very moon-like surface with craters, ridges, and chaotic terrain. The magnetometer on Mariner 10 revealed a weak magnetic field compared to Earth, and the radiometer suggested chilling temperatures of -297 degrees Fahrenheit at nighttime and scorching daytime temperatures of 369 degrees Fahrenheit. Mariner 10 looped around the Sun 3 times to head back to its target. The third and final flyby was the closest encounter on March 16, 1975. The probe was only 437 miles from Mercury, allowing it to capture unexpected details of the planet's surface and atmosphere. Mariner 10 returned more than 2,700 pictures that covered nearly half of the planet's surface. Out of the received images, the Caloris Basin was the most impressive. A massive basin with a diameter of almost 2,500 kilometers, featuring a set of concentric rings and ridges. Although Mariner 10's success proved that traveling to Mercury was possible, it wasn't until 2004 that another spacecraft was sent to observe and study the smallest planet. NASA's Messenger spacecraft orbited Mercury for more than 4 years, during which it succeeded in mapping the entire planet, among other astonishing achievements. Messenger entered Mercury's orbit 7 years after its launch, after various gravity assist maneuvers through the inner solar system and flybys. The spacecraft successfully completed its year-long mission and captured 100,000 images of Mercury's surface. Messenger revealed many of Mercury's secrets previously unknown to astronomers. One such achievement was the discovery of water on the planet's surface in the form of ice. As the probe orbited around Mercury, it was able to identify deposits in many of the shadowy regions of craters near the planet's poles that were later confirmed to be ice. We know what you're thinking. How could there be water ice on the planet closest to the Sun? Mercury has massive craters on its poles, meaning some areas remain untouched by the Sun's heat. The shadows of the craters allow the ice within to remain frozen even though the planet reaches boiling temperatures in the daytime. These shadows not only protect the ice from the Sun's glare, but also from solar tornadoes, which are an integral part of Mercury's atmosphere. Mercury has a very active surface. Its magnetic field interacts with solar winds to create powerful magnetic tornadoes. As a result, hot solar wind plasma collides with the planet's surface, spreading neutrally charged atoms into the atmosphere. Mercury doesn't have an atmosphere, but a thin exosphere made of these atoms that are blasted off the surface by the solar wind and striking meteoroids. The planet's exosphere mainly comprises oxygen, sodium, hydrogen, helium, and potassium. NASA has estimated that Mercury has at least 100 billion tons of ice. Mercury has a large metallic core with a radius of almost 1,289 miles. That's about 85% of the planet's radius. The remaining outer shell is only 250 miles thick and predominantly made of silicate rocks and metals. That's what gives the planet its grayish-brown color. There is evidence that Mercury's core is partly molten or liquid. Since it acts as a source of heat for the outer layers of the planet, it's possible that there may be liquid water underneath the frozen layers of ice within its craters. Although we don't have any evidence of life on Mercury, the possibility of liquid water suggests that there may be some form of living organisms deep inside the surface. Messenger also captured the rugged terrain of Mercury, its surface resembling Earth's moon. Mercury is scarred by several impact craters caused by meteoroid and comet collisions. There are some massive impact basins like the Caloris and Rachmaninoff that were created by asteroid impacts very early in the solar system's history. The planet also has large areas of smooth terrain, but some cliffs stretch for several miles and reach soaring heights. These cliffs are a result of the planet's contraction over the last billions of years. Most craters are surrounded by crater rays, a rock formation caused by an asteroid or comet strike. When a large celestial object collides with a planet's surface, a tremendous amount of energy is released as a result. As the impact crushes the surface into a big hole, rocks are thrown far from the crater, which eventually falls to the surface, forming the rays. Since fine particles of crushed rock are more reflective than large rocks, the crater rays appear brighter. However, that brightness reduces over time due to dust impacts and solar wind particles. Did you know the Mercury we see today is only a fraction of the planet that existed many billion years ago? Scientists analyzed images sent from the Messenger, concluding that the planet has contracted by as much as 8.6 miles in diameter over the past 4 billion years. Although scientists already knew that Mercury was shrinking, the latest images revealed that its contraction was much greater than earlier estimates. The primary reason for this shrinkage is the temperature difference between the planet's core and surface. The inner temperature of Mercury is hundreds of degrees higher than its surface temperature. In order to maintain equilibrium with the surface temperature, the heat from the core tries to escape, causing the planet to shrink. Interestingly, Mercury has a single tectonic plate, which means the planet's outer hard shell is continuous, unlike Earth, which has 7 major and 6 minor tectonic plates. When scientists studied the tectonic features of Mercury, they found its surface marked by wrinkle ridges and lobate scarps, or rounded cliffs. While there are more ridges than scarps, the cliffs are hundreds of miles long and several miles high. All these surface features point toward compressional stress that the cooling and contraction could cause, as well as possible crystallization of the planet's iron core. The images and data sent by Messenger proved instrumental in understanding the mysterious planet, but more good news is on its way thanks to the International Space Mission Bepi-Colombo. Bepi-Colombo is an international mission comprising 2 spacecraft riding together to Mercury to orbit and study the planet from various vantage points. One of the orbiters has been provided by the European Space Agency, while the other is from Japan Aerospace Exploration Agency. The spacecraft was launched in October 2018 and is scheduled to begin orbiting Mercury in 2025. Its mission includes studying the planet's composition, geophysics, atmosphere, magnetosphere, and history. Although the spacecraft has sent some images after its first flyby of Mercury on October 1, 2021, the best is yet to come. Thanks for staying with us till the end. If you enjoyed the video, please give it a thumbs up, subscribe to our channel, and press the notification bell for more exciting space videos.